totally loaded question, but would you rather $1 million now or a cent, but it doubles every day for a month?
Cent.
Yeah. Why? How much is it going to be? How much do you think it's going to be?
It's way more than a mil.
It's way more than $1 million? How much more?
I remember seeing this on TikTok.
Oh, so it's TikTok thing. Okay. TikTok thing. Okay. So yeah, it's way more than $1 million. How do we figure out how much it would be? Okay, well, how do we double something quickly? So 0.01 multiplied by 2, and then double that again, multiply by 2, then double that again, multiply by 2, multiply by 2. Yeah, so that's, how many days would this be? That'd be 4 days. So I want to do for November, so 30 days. So 0.01 by 2, repeatedly multiplied 30 times. How do I repeat multiplication 30 times? Power of 30. Okay. So I know you're saving the batteries on your calculator, so I'll do it. Anyone have a guess before I do it? 8 mil. Did you already do it? Might be 8 mil. I can't remember how much it is, actually.
I think it's like 7 point something.
7 point something? It's 1 by 10. Oh, no. Do it really slowly. It's dramatic. Oh! 10 million. 10 million. 737 and something. 10 million. Ooh. Okay, that's not very realistic. No one's ever going to give you... There's a few classic kind of problems like this. It's the one with the Egyptian emperor, wasn't it, who said I could have one grain of rice for every square on a chessboard and double it. So on the first square of a chessboard, he put 1 grain of rice, and he said, this is how I want to be paid. He was an engineer for the emperor of the pyramids. I said, I want 1 grain of rice, and then double it for each square on a chessboard, and I'll take that as my payment, which is a weird payment, every day for... So he got 2 grains of rice the second day, and the emperor thought that's a great deal. How many grains of rice did he end up with? A lot of grains of rice, yeah. So this is doubling each time as well. How many squares on a chessboard? 60, yeah, Mate knows. 64. So it'd be doubling 64 times. This penny doubled only 30 times. So think about this, just doubling it one more time would be 20 million. Double that one more time would be 40 million. That would be to the power of 32. So imagine what's going to be to the power of 64. It's actually billions and billions and billions and trillions of grains of rice. There's more grains of rice than was ever produced would be on the last square. More grains of rice than stars in the galaxy would be on the last square. Then sand on all the beaches in the world. Yeah, you got it, yeah. That's pretty good. He was pretty happy. Needed a bigger house. Okay, so this is the power of a compound multiplier. Of course, both those situations, well, the other one was made up, and this is also made up. So what happens in real life? Where do we see compound interest in real life?
In banks.
Yeah, in banks. So you often, like, if you ever get your hands on $1,000 today, so you guys are, 12?
Something like that.
Yeah. So would $1,000, would you be able to retire if you got $1,000 today when you're 65 and didn't earn any money? Would you be able to have enough money? No. Let's say you did really well. What would be a really good interest rate return? Really good.
Like 10%.
10% would be pretty good. Like the S&P, if you talk to your business teacher. Who's your business teacher? Okay, so what's a good year for the S&P? That's where the best 500 businesses in America, you buy a bit out of each one of them. A good year would be about between 17 and 20%. But it's not always that good. As you say, about averages out about 10. So let's say you had a really good year every year, and you put it into the right stocks every year, and you made 20% interest. So 20% interest, if I want to multiply that and show, I don't want to multiply by 0.2, would I? I multiply by 1.2, yeah, because I need to ensure that the $1,000 is counted as well. So I multiply by 1.2. And let's say I do that 20% interest, and you guys are 15-ish, and you do that for until you're 65. So how many years is that? A lot, yeah. That's closer than you think. 50. Let's go with 50. Some of you are younger than others, but let's say you do it till you're 65. How much money do we think we'll have? I think that's actually not an unrealistic mathematical thing. These are unrealistic. This is realistic. 20%, okay, a bit high, but it's achievable. People do get 20% interest a year. An estimate. How much do you think you'll retire on when you're 65? Not $65, 65 years of age. Okay, let's do it. Okay, so I'm going to do $1,000. I'm going to do my multiplier by 1.2. Obviously, at the end of the first year, you'll have 1,200, and then that will be reinvested, and so to the power of 50, you're going to be 9 million. 9 million. Okay? That's maybe unrealistic, so let's say something realistic. Let's go with what Leo suggested, which is a very realistic return, 10%, if you do well on the... So 10% is only 1.1. Let's try that. Uh, 10%, a little bit. How much do we think less it's going to be? It's a lot less. It's around about $120,000.
Actually?
Yeah. Okay. So one thing you could note is the earlier you get investing or saving, the better. So some like if you want to go, this is not financial advice, but if you want to go like cryptocurrencies or Bitcoin or something like that, I think Bitcoin's year on year is about 25%. So 25% would be more than this then. But obviously that's very volatile. It could go down 100% as well. But think about how much money, if you just put $1,000 in this year, you could be a multi-millionaire by the time you're 65 without doing a thing. So maybe go home tonight and move some funds around and put $1,000 somehow into stocks and shares and see what you can do. Maybe convince your folks to do that. You probably wouldn't be able to do it. You probably have to open an account in your someone over 18's name. But I think it's worth a thought and to convince people the power of compound interest. So a bad year for this would be 7%, and that's in around $90,000 and that's a bad year. So on average, investing works. So think about that when you're going to go in the future investing, or maybe tomorrow investing. But we need to formalize that process into what that is. That is something called compound interest. It's a very powerful multiplier. So compound interest is, how do I make a formula out of that? I want to make a formula out of what I just did. If I have an amount of money and I want to invest it, what do I multiply by, or to the power of, Timon? What do I multiply by?
8 times interest.
So I multiply by, okay, so the interest rate has got to be written 1 point something, doesn't it? As a percentage. So I can do, the rate is 1 plus the rate, maybe, the interest rate as a decimal. And what do we do? If it was 2 years, we had it to the power of 2. If it was more years, we had it to that power. And that's the number of years I put as the power. So for example, if I have an example then, if I have $100 at 10% interest for 10 years, I would put the amount as 100. I would multiply by 1 plus the rate as a decimal. This rate as a decimal is 0.1, so that's 1.1. So you're making 110% the first year. You know you're going to have $110. And I'd put that interest rate to the power of 10. And then I would use my new fancy calculator. I'm going to use my old non-fancy calculator. 1.1 to the power of 10, and I get out around $260. Did you get it? 259? Yeah, 259. 259 rounded to the nearest dollar. So just $100 will go 2.5 times bigger in 10 years at 10% interest. Okay. So that is compound interest. We can use this as our formula. There's a fancier looking formula. It might be somewhere up there. If anyone can see the compound interest formula. There's a fancier formula you can use, but I think this one is pretty straightforward. The amount of money and 1 plus the interest rate. So remember, it's 100 and something percent. Simple interest is what? What's the difference between simple interest and compound interest? Miles, you must know. No. Leo?
Simple interest, let's say you put $100 in for 10 years.
Yeah.
You would only get like $10 every year. It doesn't
Yeah.
change. So if you get $10 the first year, you don't then get 10% of $110. You get 10% of $100.
Exactly, yeah. So you're only getting the percentage off your initial amount. You don't get any extra percentage. So simple interest then, if I have $100 at 10%, the amount I would earn after 10 years is, well, each year I would earn 10%. So that's 10, 10, 10. You just add it up, and it would be $200 after 10 years. So simple interest is where we don't include the amount you've made. It's the more unused one. So banks would never, ever use simple interest. They always use compound interest. And you wouldn't want simple interest for if you're saving. You might want it if you have a loan. But if you're saving, you don't want simple interest. But it is, simple interest is the amount multiplied by the rate as a decimal, multiplied by the years, not to the power of years. Miles, move again here. And this doesn't give us anything other than the interest. So if I have, for example, if I have $2,000 invested at simple interest at 2% per annum, which means every year, for 8 years, I would do the amount, which is 2,000, multiplied by the interest rate, 0.02, that's 2% as a decimal, multiplied by 8. Now you could probably do that in your head, but we'll do it on a calculator. $2,000 multiplied by 0.2 times 8 is 320. Now notice that says the interest, it doesn't say the total. So that is only the interest, so the amount you would have is 2,320. You'd have to add it back on. Yes?
What is that word that says that's often 2%
Per annum. Yeah, I didn't write that. Yeah, annum is it's a way of saying per year. Or some say an annual interest rate, which means per year as well. So yeah, I'm using that because it's a term that's used in questions